This is the sixth video on the National 5 topic of similarity, and this video will be looking at the volume of similar shapes. What I'd like you to do is, if you look at this slide, pause it and just calculate the volume of each of these three cuboids, just in the space below. So for this one, if you can do the volume in that space there. So, volume of a cuboid, length times breadth times height. 2 by 3 by 2 in this case. For the first one, gives me 12. Second one, length times breadth times height. 4 by 6 by 4, giving me 96. The third and final one, length times breadth times height. 6 times 9 times 6, which hopefully you've been able to calculate was 324 cubic centimetres. The connection between these volumes doesn't seem that obvious to start, but if we notice, looking at the first two, the 2 and the 4 correspond, the 6 and the 3 correspond, and the 4 and the 2 correspond as well. There's a linear scale factor. The sides have been multiplied by a factor of 2. So, you can think of length times breadth times height, but instead of thinking I've got a length of 4 centimetres, it's really 2 multiplied by this scale factor of 2 here. The breadth, I can think of it as 6, or I can think of it as 2 lots of 3. So times 2 lots of 3. The height, instead of thinking of it as 4, I can think of it as 2 lots of 2. Note, I've got 2 times another 2 times another 2. I'm multiplying by 2 3 times. I've essentially got, if I tidy this up, 2 cubed. 2 cubed, and 2 times 3 times 2, well, that's just my volume of my original cuboid. So, a linear scale factor of 2 has given me a volume scale factor of 2 cubed. Let's look at this third one. Again, the 6 corresponds to the 2 on the original. The 9 corresponds to the 3 on the original. The 6 for the height, it corresponds to 2 on the original. All of these are 3 times bigger. So I can reconsider my volume, length times breadth times height. 6. The 6 here is 3 times the original 2. The breadth, my 9, it's 3 times the original 3. The height, this 6 here, is 3 times the original 2. And just quickly fixing that typo there. So that should be a 2. So, notice 3 times 3 times 3. I've got 3 cubed times 2 times 3 times 2 times my original volume. I've got 3 cubed times 12. We can say our volume scale factor is just our linear scale factor cubed. Okay? Think about it. Volume's a 3-dimensional quantity. Okay? So the cube reflects that. It's the 3 sets of lines, my length, breadth, and height. Okay? If I take this middle cuboid apart, well, let's think. This 2 cubed. 2 cubed is the same as 8. And watch. So I just break this down. I've got 1 of my original cubes. 2, 3, 4, 5, 6, 7, 8. 8 of my original cubes. 8 lots of my 12 cubic centimetres. Again, for the bigger one. 3 cubed. 3 times 3 is 9, times 3 again is 27. And notice, 1, 2, 3, 4, 5, 6, 7, 8, well, 9 in that layer, 4, 5, 6, 7, 8, 9, another 9 in that layer, so I've got 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I've got 27 lots of this original cuboid here. So if we know the linear scale factor, if we say that's S, the volume scale factor is S cubed. So find the missing value for each pair of similar shapes. So looking at these mugs here, I know the height of the first one is 8. I know the height of the second one is 12 centimeters, putting in my units, and I need to find the volume of the larger one. So I find my scale factor, my linear scale factor, by comparing my corresponding dimensions. I know the two heights. Now simplifying that, 20 and 8, they're both divisible by 4. Give me a scale factor of 5 over 2. My volume scale factor, well, that's going to be 5 over 2 cubed. Now, if you're using a calculator, you could leave it like this. Alternatively, 5 times 5, 25. Times in that by 5 is 125. On the bottom, 2 times 2 is 4. Times 2 again would give me 8 for my scale factor. So my volume of the larger one, a larger larger cup, sorry, is I need to take 160 milliliters, the volume, and times it by this new scale factor. Again, looking at these numbers, these are potentially things you could work with in a non-calculator paper. 16, the 160, sorry, and the 8, they're both divisible by 8, giving me 20 over 1. 20 times 125. Well, two 125s are 250. And I would need to times that by 10, would give me 2,500 milliliters, which I could write as 2.5 litres if I wanted. The second problem, so I've got blocks of precious metal. I know the first one is 15 centimeters long. Material used costs 330. How much would it cost to make a similar block? I note the word similar. Block of 6 centimeters long from the same material. And that's detailed in the picture. Remember, the cost depends on how much material is used. So while it hasn't said we're working with volume, how much material you've used depends on the volume. So, my linear scale factor, I've got my corresponding dimensions, 6 over 15, dividing both of those by 3 would give me 2 over 5. For my volume scale factor, it's going to be that cubed, 8 over 125. My cost, I would need to take my £330, times it by this volume scale factor. And again, I think, just going by experience, this would probably be a calculator question, just looking at those numbers. So plugging that into my calculator gives me that. £21 and 12 pence.